Newton's first law of motion and Newton's second law of motion tells us about force. About what force is, what is its mathematical formula. So, what is the importance of Newton's third law of motion? What does it tell us and why should we study it? To know all this stuff, watch this video complete. Hello everyone, this is Devinder Kaur and you all are welcome to my YouTube channel, The Enlightened Room. Newton's third law of motion states that to every action there is always an equal and opposite reaction. That means the forces in action and reaction are always equal and opposite. These forces act on two different objects and never cancel each other. Each force produces its own effect. Although action and reaction forces are equal in magnitude, yet these forces may not produce accelerations of equal magnitude. Well, this is because each force acts on different object which may have different mass. So, the force acting on lighter body will produce greater acceleration and vice versa. Now, let's discuss some examples of Newton's third law of motion to know this formula, to know this law of motion more. Well, the first example is walking. Yes, the first example of Newton's third law of motion is walking, and we do it very often, right? Unless if you're not that much lazy. So to walk on ground, we push the ground backwards with the foot, and as a reaction the ground pushes our foot forward with the same force. It is this forward reaction force of the ground that enable us to walk forward. Walking becomes difficult when the ground is slippery or it is covered with snow or sand or oil. Well, this is because we can exert much smaller force in the form of backward action on the ground. The forward reaction of the ground will reduce accordingly. Now the next example is swimming. While trying to swim, a swimmer will try to push the water backwards with its hands and feet, and this pushing the water backwards is the force of action. The water pushes the swimmer forward with the same force, and that force is the force of reaction. So this also proves in Newton's third law of motion. Now the next example is, you have to suppose there is a sailor who is in his boat and the boat is at rest near a river bank. Now as the sailor jumps from the boat to the river bank, the boat is pushed away from the bank, and this happens due to the equal forces of action and reaction. The next example, which is important for the numerical and questions point of view, is recoiling of gun. When a bullet is fired from a gun, the gun recoils. That means the gun would move backwards through a small distance, giving a jerk to the shoulder of the gunman. Well, this is because on firing, the gun exerts some force on the bullet, and that force is in the form of action in the forward direction. In turn, the bullet exerts an equal force on the gun, which is a form of reaction in the backward direction. The distance moved by the gun is much smaller than the bullet because gun is much heavier than the bullet. That means it has much more mass as compared to the bullet. The next example is also important. It is about the flying of rockets and jet planes. Well, in a rocket, the fuel burnt appears in the form of hot and highly compressed gases. These are made to escape through a nozzle in the downward direction. As a reaction, the rocket moves upwards with the same force. The force of action and reaction can be shown here in the given picture in front of you. Now, while in the case of jet plane, the burnt gases rush out of the jet at the rear end, or you can say the back end of the aircraft. So as a reaction, the jet plane moves forward with an equal force. Now one more example of Newton's third law of motion is the case of hose pipe. Now to put out fire, the fireman direct a powerful stream of water on fire from a hose pipe, and while doing so, the hose pipe is to be held strongly because of its tendency to move backwards. As the water rushes out at the great speed from the hose pipe in the forward direction, which is in the form of action, the hose pipe tends to move backwards due to an external force of reaction. So we have discussed about Newton's third law of motion and the various examples of Newton's third law of motion. To get more videos related to your science topics, subscribe to my channel and click on the bell icon. Thank you so much.